Hello, my name's Vanessa Moran, and I did my presentation on methane hydrates or methane clathrates. So let me just share my screen. Mm. Okay, so figure A here is a picture of a methane hydrate. This sample here was obtained from the sea floor during a research expedition off the coast of Oregon. And then figure B here is a close-up of methane hydrate observed at a depth of 3,460 feet off the U.S. Atlantic coast. As we know, methane is an important energy source. We use it daily in our homes for heat and cooking. It's also used in diesel gas engines and to make rocket fuel, and it has many other uses. What is a methane hydrate or a methane clathrate? Um, It's what they call the natural gas when it's trapped inside ice. So as we can see here, um, it has a clathrate compound or lattice that traps molecules, gas molecules, inside of it. The structure resembles an ice-like honeycomb. Um, Methane gas is primarily formed by microorganisms that live in the deep sediment layers and slowly convert organic substances to methane. It occurs naturally in the ocean where water, methane gas, low temperature, and high pressure conditions are favorable for its formation. These conditions are illustrated in the phase diagram on this page. If the ice if the ice is removed from the temperature and pressure environment, it becomes unstable. This is a reason why methane hydrates are difficult to study. The deposits cannot be drilled or cored for study like other subsurface materials because as they are brought to the surface, the pressure is reduced and the temperature rises. This causes the ice to melt and the methane to escape. Figure C shows a phase diagram with water depth pressure on the vertical axis and temperature on the horizontal axis. The dashed line separates stability fields of water, water ice, gas, and gas hydrate. The line labeled hydrate to gas transition is significant. Um, Conditions for the formation of methane hydrate occur below this line. Above this line, methane will not form. So where can you find methane hydrates? They are common and restricted to the shallow lithosphere. There are four environments that have the temperature and pressure conditions suitable for formation and stability of methane hydrates. The first one is continental sediment or sedimentary rock units in polar regions where surface temperature is less than 0 degrees. The second is sedimentary deposits along continental margins in the ocean, greater than 300 meters and around 2 degrees Celsius. The third is the deep water sediments of inland lakes and seas. And the fourth is in Antarctic ice, um, which also they're in the ice cores. And there's a record of the atmospheric methane concentrations in the ice cores that have been drilled out, and they're the primary source of data for global warming research. Figure D here is a map of the world where methane hydrate deposits are. The red dots are where they believe there are deposits, and the purple is where samples of the deposits were collected. Detection and monitoring methods of methane hydrates. So presence of methane hydrates changes the physical properties of marine sediments. They have studied fluid flow of sediment and rock physics, as we all use geophysical methods like electrical resistivity, seismic reflection monitoring, multi-beam sonar, and drilling to learn more about the hydrates. The multi-beam sonar specifically the sound waves are used to detect the methane bubbles and map the sea floor. The technique calculates the time and distance it takes for sound waves to travel through the ship to the sea floor and back. The sonar can also detect the density contrast between gas bubbles and seawater. Organisms are also used to detect deposits. Marine organisms like sea urchins, mussels, spider crabs that live near the gas seeping areas can be used as indicators. And here in figure F is just a picture of a seismic exploration technique to find hydrates. So some pros and cons about extracting methane hydrates. A con is a dissociation of methane hydrates can increase the temperature in the atmosphere, contributing to climate change. This gas is more powerful and is known to trap heat better than CO2. Burning the gas will add to the accumulation of greenhouse gases in the atmosphere. It is hypothesized that these methane hydrates were the reason for the Paleocene-Eocene thermal maximum, which is when the average global temperature rose and massive input of carbon was released into the atmosphere in late Paleocene, early Eocene. However, recent studies have suggested that once these methane hydrates are dissociated in the ocean, it is difficult for them to reach the atmosphere and they react slowly to warming. Many people also worry that the extraction of these gas hydrates will disrupt habitats and ecosystems. Um, but how methane hydrates can help, they're believed to be a larger hydrocarbon resource than all the world's oil, natural gas, and coal resource combined. If these deposits can be efficiently developed, methane hydrates could become the next energy game changer. These deposits have the potential to help countries that currently import natural gas to become self-sufficient. The current challenge is to find a safe, economical way to develop it. To date, there has been no large-scale commercial methane production from gas hydrate deposits. All of the production has either been small-scale or experimental. The clathrate hydrates has been a great interest for technology and applications like seawater desalination, gas storage, and carbon dioxide capture and storage. As we know, global temperatures are rising, warming the oceans and melting glaciers, and the enormous reserves of methane hydrates trapped in the ice are going to be released naturally. The consequences could be catastrophic as these warming temperatures release more methane, which in turn raise temperatures further. Therefore, monitoring the gas hydrates is extremely important and urgent. And that's it. Thank you.